Notice, and this is the typical copyright, we continue with mathematics syllabus for CSEC 2018. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged. The main planned change to the CSEC level math exam is to split the exam into two parts. This is the current structure of the CSEC math exam. There is a paper 1 hour, 30 minutes, made up of 60 multiple choice questions from all sections of the syllabus as shown below. For paper 2, 2 hours, 40 minutes. This paper consists of 10 compulsory structure type questions from all sections of the syllabus. There is no choice. All sections will be tested. I had previously mentioned that there was a choice, but that was for the previous syllabus. As of this syllabus here, there is no choice. And then there is the SBA, school-based assessment. If you are a student in school, that is done in the school itself, directed by the teachers, guided by the teachers. And if not, you will write an alternative paper for 1 hour along the same pattern as the SBA structure. So paper 01 or paper 1 carries 60 marks from 60 questions, which eventually works out to be 30%. Paper 2, 100 marks, which will work out to be 50%, and so on. Paper 3. These are the various profiles, knowledge and the percentage, and comprehension and reasoning. Schedule of videos, sections 1, 2, and 3. All 51 of these videos have been published in their entirety on YouTube. Please make good use of them. Sections 4, 5, 6, and 7, these are all completed. From this section, 5 videos have been published in their entirety. From this section, 5 more. From this section, 7 more. And lastly, from section 7, 9 more. Those are videos that have been published in their entirety. The other videos are completed and only partially published on YouTube. We are now at section 8, geometry and trigonometry, and this is the third of 24 videos. After that, of course, we have to do section 9, vectors and matrices, and hopefully by May, June 2026, all of these videos would be completed. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. Returning to section 1, I have divided that into 33 videos, and as I just said, they are all available on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. Another reminder down here, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Revisiting section 1, some of these videos are even applicable in the primary school for students who could use them on their own, for teachers who may use them in the inverted classroom, and especially for parents who may need the assistance to help their children at this level. For example, if I expand this blue box up here, you will notice video 6 says add, subtract, multiply, and divide whole numbers. That is work done in grade 3 of the primary school. And then video 7 says add, subtract, multiply, and divide decimals. That's grade 4 work. Videos 8 and 9 would be grade 4 and grade 5 and grade 6 work, where you have to add and subtract fractions, that's video 8, and then multiply and divide fractions, that's video 9. So, primary school work from section 1 of the CSEC syllabus. Section 2, as you know by now, all 12 of these videos have been published in their entirety on YouTube. Section 3, sets, all 6 of these videos have been published on YouTube in their entirety. Section 4, measurement. Some of these videos have been published on YouTube in their entirety, as you see here. The others only partially published. If you need to have full access to these videos that are only partially published on YouTube, please see directions in the description below. And this pattern applies for the next 3 sections. Section 5, statistics, some published in their entirety, others only partially published. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 6, algebra. These 7 videos are published in their entirety on YouTube. The others only partially published. Again, the same pattern applies if you need full access. Section 7, relations, functions, and graphs. These that you see here have been published in their entirety on YouTube. The others partially published. Same principle applies if you need full access to these videos that are only partially published. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2 to get more practice questions. CSEC recommends these shown on the right here. From those, I would recommend these last 2 down here, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current and the future proposed changes in the structure of CXC's CSEC math examination. This is a picture of volume 1, Mathematics, a complete course with CXC questions by Raymond Tulsi, and this is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such a question. This is the URL for that website. On the next slide, I will show you what the home page looks like. This, you would have to register first and then sign in. This is that URL again. That URL will be in the description of this video below, so you can easily click on it and be redirected to this website. Just a reminder that this formula sheet you see on the left is provided for CSEC examination papers, math. This formula sheet you see on the left here. It is included in a full copy of the syllabus. Just in case you don't have such a full copy, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little better. And I will state the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the examination. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. This is a print screen of the first page of the syllabus from section 8 as it relates to geometry and trigonometry, the section we are now doing. We have completed objective 1 in 2 videos, and we are now at objective 2. Print screen from the next page in this section, and the next one, and the next one, and finally the last page with specific objectives in this section, 17 objectives. So as I said, we have finished those 2 up there. The first one is published in its entirety, the next one only partially published. We are now here at 8_2. When this is finished, as video 3, it will only be partially published. Projection for the rest of this section, those will be the videos that are published in their entirety from this section when they are completed, and these others partially published. So as I said, we finished objective 1 in 2 videos. Now we are at objective 2, and it says draw and measure angles and line segments accurately using appropriate instruments. So there are 4 specific components that are clearly stated. Here they are: measure angles accurately, draw angles accurately, draw line segments accurately, and measure line segments accurately. We will follow them in that sequence. And it says using appropriate instruments. So you will need what is called a set of mathematical instruments. We sometimes call that a geometry set. You will find in it a pair of compasses, a pair of dividers, a protractor, and 2 set squares, and a 15-centimeter ruler, and 1 or 2 other items. So this is the protractor that we will need to measure angles and to draw angles. This is the pair of dividers. I know it looks like 1 item. And this is the pair of compasses. It looks like 1 item, but that is what they are called. And over here we have a set square. This ruler that you would get in the mathematical set would only be 15 centimeters. You may need to buy a separate one that is 30 centimeters long. So we begin here. Measure angles accurately. You will need a protractor, preferably a transparent one. So let us say you are asked to measure that angle ABC. Trick question. You actually have 2 angles there. Which one are you supposed to measure? To indicate which angle you need to measure, an arc is placed between those 2 arms, like this. So now we know we're supposed to measure this smaller angle here, the acute angle, and not the reflex angle out on this side. Out on this side. So you need to do 3 things. Make sure that that center of that protractor rests here at this vertex, that this 0 rests along this line, BC, and that this scale here falls between these 2 arms of the angle. You must make sure you have all those 3 things in place before you can measure the angle. So it looks like this. That is in place. This is in place. And this scale here is between the arms. And now you can read it, beginning at 0 here. 0, 10, 20, 30, 40, 50, 60, 70. That is 70. Do not confuse it with that 110 up there. You can rotate the protractor like this. Remember, that must be where that must be at the vertex. A0 must be on that one of the arms, and this scale must be between the 2 arms. Now you can read it, but this time we are reading from the outside scale, and we arrive at 70. Down here, we were reading from the inside scale. We are reading from 0 from 0 along the scale until we reach the other arm. What not to do. Please don't do this, and you may think you have two things right. That may look right. You have a 0 along one of the arms, but how are you going to read that? We need this scale to be somewhere along here. So maybe we could rotate that protractor a little to make that 0 up here, and then we will be able to read it. Now, what about this? Same wrong thing as over here. That may look right. This may look right. You have a 0 along one of the arms, but where are you going to read the degrees? If you could rotate that a little down this way to bring that 0 to this point, then at least you would have this scale to read. So those two are wrong. And to make matters worse, please don't do this, because this is even more wrong, if I could say so, than the previous two. You only have one thing here basically in place, but look where this 0 is. It is not here, neither is it there. You do have a scale somewhere here, but it doesn't extend down to here. So please don't do this at all. So this is the angle we want to measure. We take our protractor and set it up like that. Beginning here, we go like that. We arrive at 70, and you write in here 70 degrees. And down here, you name the angle and say how many degrees it is. So angle ABC is equal to 70 degrees. This letter here at the vertex always falls in the middle of the name. It could be ABC or CBA, but B must be middle there. You always use uppercase letters to name an angle. We need to measure this angle here, this angle here. This is our protractor. Set that point here, set this 0 along BC like that. You have to be very precise, and that's about it. Make sure that this scale is between these two arms, and you read from 0 here, 10, 20, 30, 40, 50, 60, 70. So that angle is 70. As you could see, it is an acute angle. So you write in here 70 degrees. So angle A, B, C is equal to 70 degrees. Now, if we have to measure this angle here, by now you know what to do. You set your protractor like this. Make sure that point is there at the vertex. Make sure you have this 0 on this arm, and that you have this scale along here that you could read. So let's read it. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So this angle here looks like 120 degrees. Do not get confused with that 60 up there. You could have placed a protractor like this. That is in place. This is in place. And this scale is between these two arms. But now you would begin reading from this 0. And you would come this way, 80, 90, 100, 110, 120. So either way, you still get 120 degrees. So angle DRP is equal to 120 degrees. Or you could write it slightly differently. It still means angle DRP. Let's measure angle DRP. This is an obtuse angle. So our protractor here can measure up to 180. So again, you set that point here, this 0 here, like that. Make sure the scale is between these two arms, and you read from 0. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Now, don't be fooled by that 60, because that is if you are reading from this side. So this angle here is 120. You could have done this as well, even for the previous one. But now you are starting from this 0, not that 0 that we were using to begin with. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. 20. So this angle here is 120 degrees. 120 degrees. You write angle DRP is equal to 120 degrees.